Hey guys, today we'll be working on the 2000 problem 23. So let AB be the diameter of a circle and C be a point on AB with 2 times AC is equal to BC. Let DE be points on the circle such that DC is perpendicular to AB and DE is a second diameter. What is the ratio of the area of DCE to the area of ABD? Well, let's set some values as variables. So let's set AC here as x. So we have this as x. Then we know that BC, this, would be 2x. So we know the total diameter of the circle, this whole thing right here, from AB is 3x. So let's write that down. The diameter is 3x. So because the diameter is 3x, we know the radius is going to be half of it. So that's 1.5x. And one thing we can take from here is we know that from this point to A is going to be one of the radiuses. So we know A to this point right here is going to be 1.5x, and we know AC is already x. So this part is going to be 0.5x, which we can write as x over 2. And let's go back to the question. So the question asks, what is the ratio of the area of triangle DCE to the ratio to the area of triangle ABD? Well, let's see. How can we find the area of ABD? So one way we can find it is we could take the base multiplied by the height. We can have AB multiplied by DC. So let's write that down. So we have the area of ABD is going to be 3x times DC over 2. And we know the area of the other one, DCE. Well, let's find, how do we find the area of DCE? Well, let's take the base DC. So if we want to find the height, it would be the length here, would be its height. So it would be DC times, let's set this length to be something like y. So DC times y over 2. And we know that because we're finding the ratio, we can multiply both by 2, so we don't have to consider for taking the half. Well, now we just know the ratio of DCE to ABD is going to be DC times y over 3x times DC. And then we could simplify and divide by DC on both the top and bottom, so we get y over 3x. Now all we need to find is y. Let's find what y is. Well, one thing we can take here is let's take the triangle DC to that point and D here to E. Well, we know that these two triangles are similar. How do we know that? Well, according to AA similarity, they must be similar. Because we took this length as the height, we know it's perpendicular to the line on the base. So we know this angle right here is itself, and there are two right angles. So by AA, they're similar. So let's just label some points here to make it easier. Let's make this O because it's the center of the circle, and we can have this be F. So we know triangle DCO is similar to triangle DFE. And because of this, well, we know DO is one of the radiuses. So we can put this as x. And we know D to E is the diameter. So it's going to be right here, we have it, is 3x. So DO over DE is equal to 1/2. That's the ratio of the side lengths. And then we want to find x over 2, or no, let's write it as the side length. So we also know that CO is going to equal to this ratio. So we know CO is x over 2, so x over 2 over FE, which is y, is going to equal to 1/2. Let's cross multiply, so we have y is equal to x. And because y is equal to x, let's take this ratio of the areas here. It'd be x over 3x, which we can simplify down to 1/3. So that's the area, that's the ratio of the areas. So that leads us to answer choice C.